Oh, let's see. Hopefully, like the mic's not like last time and it actually works. But so today we're going over the big poppy problem. So I believe, yeah, this is question 21. I'll just write this up here. Question 21. And basically, in short, saying Big Poppy hits the ball with the fence 105 meters away. And the fence is also 1.4 meters higher than where he hit it. The ball left at a 31-degree angle. And so what this question is asking you to find is with what speed did the ball leave the bat? What speed did ball leave? Sorry, it's kind of hard with the mouse, but there we go. So in short, this is just asking for our V naught, which is also like the V0 looking thing. So to sketch this out, let's just do Big Poppy's over here. You see him, he's just like, he has a little, let's just draw that little bat. He hits the ball, and it's basically going all the way, and the fence, which is right here, is 105 meters away. So that is really just our delta x. Our delta y is, so like we also know that the fence is plus 1.4 meters up, and that this angle right here is going to be 31 degrees. So now what we're going to do is we're going to sketch the little triangle, which is just the vector arrows that it forms. So in short, this is really just, there's one arrow going that way because he hit it towards the fence. Gravity's acting down, so there it is. And then horizontal is going the same way, in which the vector, the original V naught, is going. So this is V naught. This is 31. And so Vx and Viy. So there we go. So we know Vx is really just cosine of 31 degrees. And what that is, multiplied by the hypotenuse, because cos is, you can also remember it as SOHCAHTOA. Ka is adjacent, adjacent over hypotenuse. So multiply it by V naught. For the VIY, which is velocity, the vertical velocity initial, we just use the sine of 31 degrees times V naught. So what that's going to give us is our chart for the y value. So let me just clear all this. Oop, that's gonna, wish there's like a better eraser feature, but yeah. Alright, this is kind of laughable. So now let's just draw a little chart. So, oops, that's a little bit, it's not gonna work. It's just right about here. It should give us plenty of space. These are our x and these are our y components. So we know that the Vx is cos 31 V naught. Delta x is 105 meters, And time, we do not know. Time is the most important thing that we're going to be looking for. So let's just try to get that done. So we also know that the VIY on this is sine of 31. Oh, that's a 3 over here. Sorry, I was just looking. Oh, I don't know. Sine 31 times V naught. We do not know the V, Y, F, V, like the horizontal velocity final. What we do know is the acceleration due to gravity, and that's always going to be, it's always going to be minus 9.8 meters per second. I just like bit my tongue, so we're struggling here. Meters per second squared. There we go. Time we also do not know, so we're going to use that as a question mark. And the delta y is actually going to be plus 1.4. That's because how high the fence was. Now we can look at our equation chart, and we're gonna first have to get time, because pretty much all of them use time or require another variable. So time we can plug into other equations. So let's just do that first. So we know that time is really just the delta x over the velocity v of x. And so when we plug that in, we're going to get time is equal to 105 over the cosine of 31 times v naught. So with that aside, just box this off. What we can do is we can just plug it into our other equation. So now the delta y on our equation card is really just equal to the VIT plus 1/2 AT squared. And what I like to do is I like to just plug it in. So we're just gonna use 1.4 is equal to sine 31 sine 31 v naught times 105 over the cos 31 times v naught. And next we can just add the 1/2 times 9.8. I'm just going to simplify this, so we're going to get, this is actually going to become a minus because of the negative. And then when you square a number, it's always going to be positive unless it's imaginary, but we're not dealing with imaginary. So we're going to get minus 4.9, and then we're going to get 105 over time, which is cos 31 times v naught squared. So now what we can do is that we know from geometry last year, I'm pretty sure what you can do is, because sine is opposite over hypotenuse and the cos is adjacent over hypotenuse, really you can just rewrite that and get tangent. Tan 31. So we get tan 31. And then we also see that there's two v naughts, and one's in the denominator, one's in the numerator. So this, along with this, oops, my dog's barking. This, along with this, cancels out, and we really just get tan 31 times, well, this thing wouldn't let go, times 105. So we can also next just simplify this part, which we're going to get plus, plus minus negative, let's put this all in parentheses, negative 4.9 times 105 squared over cos, let's just say cos 31 squared times v naught squared. So that's just gonna, equal, almost forgot something crucial, that would have been really bad. It's equal to 1.4. So with that aside, now we can just simply use our calculator and find this out. So I'm just gonna quickly plug this in. Okay, so 1.4 is equal to 63.09 minus, what's that? Let's just plug this in. Minus 735. Oh. Hold on. Yeah, it's like a huge number. I would just like edit this out, I don't know. 5 squared x 4.9. Alright, there we go. So we're gonna get is equal to, and then when we like divide it by the cos of the square, the quantity is square, we get 735 26.431. So we're just gonna cut it off at 2 decimals over v naught. So next what we do, we're just gonna transfer that, and we're gonna get negative 61.69 is equal to this, almost forgot the square, is equal to negative 7352641, oops, add the point there, over v naught squared. So now we can do multiply that. So we just do that there, and then from by the redistribution, we'll get v naught squared really just equal to is equal to 73526.41 over negative, and like these are negative, so they're auto gonna cancel out 1.69. And to solve this, we're just gonna square the whole, like both sides. So I'll just write this right here. So when we do that, we're gonna get v naught is equal to, let me just plug this, there's my calculator. That's a loud sound, my bad, I did not mean to do that. It's just, no. Square root, and then put in the fraction sign, 73526.41 over 61.69. We're going to get 34.52, and So V naught is really 34.52 meters per second, and that is the speed the big poppy hits the ball out of the park. Hopefully this helped you. It's a long video to make, but yeah, so I think that's correct. So there we go.